Hello, boys and girls. Welcome back to another edition of Crush Lusher Television. All right, so today we're going to do instantaneous rate of change, which is the slope or rate of change at a particular point. And we know that in the real world, nothing is necessarily linear. A lot of things have curves and are varied. So just like if you're driving and you need to find your speed at exactly one point, you're not driving the same speed at all times. So that's your instantaneous rate of change. Like when you're driving and one of those cameras go off, they are finding your instantaneous rate of change through a bunch of calculus. And so we're going to show the beginnings of how that works. So if I want to know the rate of change, so here's a parabola, right? So the rate of change at any point is different. So like over here, the rate of change, the slope of like a point here is negative. The point here is also negative. And then the point down here, this slope is 0. If I want to know the slope at -1, this slope right here, how do I get that? So that's what I want. So I know it's a positive something. So that's like what, +1, +2, up 2 over 1. I don't know what that is. And so what I'm trying to do here is trying to find the slope at 1, and this means slope. The slope of f, and this is f of x here, at 1. And so it gives me all of this stuff, and you watch a couple of videos on this, and it's kind of confusing, so I'm going to explain it again. So before, when we're finding average rate of change, we would just pick 2 points here, and then connect them, because that's what we know how to do. We know how to connect the 2 points, and then we can sort of guess what the slope is here. But what we're going to do is we're going to take these 2 points, right? So let's take this point here. So if I want to know the slope at -1, sorry, it should be -1, my bad. Slope at -1. We know that this point here is going to be -1, comma, f of -1, whatever that is. So that's the x, and that's the y. Probably 0, but yeah, let's leave it like that. So -1 and f of -1. Now this right here, what happens if we just move this point closer and closer together? So this point here is going to be -1 plus h. And that's the distance on the x. So that's the distance right here. So h is the little distance. So it's -1 plus a little distance away. Comma, sorry, I don't mean to close the parentheses, I mean comma, f of -1 plus h. So that's this point right here. But this point I'm moving closer. And so h is the distance on the x and the y that is apart. So now we're going to move these closer together, and we learn how to do that through a limit. So as h approaches 0. So as the distance between the 2 points approaches 0, which basically means we put them together, I can know the slope at exactly that point. So what's all this crap? Well, we did before when we had slope, right? 1, 2, 3, 4, something like that. We did the change in y over the change in x. So the change here is 2, and the change here is also 2. But how do we get that if we don't know? So that's the same as the bottom minus the top, right? 4 minus 2. So the slope here, 4 minus 2, is 2, right? That's a change in y. And the denominator is 3 minus 1, which is also 2. So that's essentially what we're doing when we do our chart to find the slope. So the slope of this point, now, I'm going to do it this way. So it's clear and we can create an equation. So the slope here is going to be, so f prime of -1. So the slope of -1 at exactly this point is positive something. So that's going to be the change in y. So the change in y, so if I draw a chart, f of x is the same as y. So I got 1 point here, and this point here. And then the other point is, bam. So it's this minus, so it doesn't matter which one you do as long as you're consistent. So it's this minus this. So it's going to be f of -1 plus h minus f of -1. Just like this is right here. So if you go, so you can go bottom to top, or you can go top to bottom, as long as you're the same. So this is -1 plus h minus negative 1. So it's this minus this and this minus this. As long as you're consistent, it's good. Or you can go bottom minus the top. Okay, or top minus the bottom. As long as you're consistent on the x and the y, it's the same thing. You're going to get the same answer. So in this case, look at this. So this is negative 1 plus positive. So it's negative 1 plus 1, which is 0. And 0 plus h is just h. So I want to know what the slope is at negative 1. Exactly that. So I find the limit as h approaches 0. So that means the distance between the 2 points is approaching 0. You're bringing them infinitely closer together. So it's pretty much negligible, so they are close together. Of f of negative 1 plus that distance minus f of negative 1 over h. So this is how you find that particular slope. And so this is the calculus version about how to find the instantaneous rate of change at any particular point when something is not going at a constant speed or a constant rate, which is like most things in the real world. And so the algebra stuff that we learn was pretty much very basic and not applicable to the real world as much. But this right here, this calculus, is how the real world works. And so now let's keep building. Let's do this problem. We're doing good. So now, same thing. So this actually was the equation, the last one. G of x equals x squared plus 3x plus 2. This is a parabola. So I want the slope at negative 1. This is how you do it. So f prime of negative 1, this means the slope, equals the limit as h approaches 0. You need to write that because that means the distance between the 2 points is getting closer and closer together, so you can find the slope at that one particular point and not 2 anymore because that was basic, that was algebra. Now we're doing calculus. Oh yeah. Of f, sorry, this case, this is g, my bad. So it's g of negative 1 plus h minus g of negative 1 over h. Okay? So now you're thinking, what the hell do I do now? Well, g of negative 1, we've done function notation before. You just plug in a negative 1 here. And then g of negative 1 plus h, you're just plugging negative 1 plus h in here. So this is going to be a big-ass problem, so check it out. So the limit as h approaches 0. So first thing I'm going to do is unplug negative 1 plus h into both x's here. Just like you normally would. I'm ignoring all this stuff. So I'm going to plug in, do a bracket here. So it's negative 1 plus h squared plus 3 times negative 1 plus h plus 2. Bam. See what I did? I just plugged in negative 1 plus h into both x's right there. Minus, okay, g of negative 1. So all I'm doing is I'm plugging negative 1 into my function. So that's negative 1 squared plus 3 times negative 1 plus 2. Bam. Over, whoop, small denominator, there's h right there. So I'm bringing that h down. All right, so next thing, what are we going to do? We're going to simplify this a little bit. So negative 1 plus h squared. So I need to do the box method, yeah. Negative 1h, negative 1h. So negative 1 times negative 1 is 1. This is negative h, and h squared. So this right here is going to be the limit as h approaches 0. Take your time with this. Write it all out. So this is going to be, I'm going to write the whole thing. So it's h squared minus 2h plus 1. Okay, so I just boxed this and I got this. Now this I'm going to distribute. 3 times negative 1 is negative 3. 3 times h is 3h, and then I got the plus 2. Bam. So I just simplified all of this to all of this. Minus, let's keep going. Negative 1 squared is 1. This is 1 minus 3 plus 2. So 1 minus 3 is negative 2. Plus 2 is 0. Yeah, cool. All right, all over h. Don't forget that denominator. I forget the denominator all the time. Okay, so equals the limit as h approaches 0 of, let's see what we got here. So we got h squared, combining like terms. So I have negative 2h and 3h right there. So negative 2h and 3h is just h. And then I have 1 minus 3, which is negative 2, plus 2 is 0. So all this equals 0 over h. Don't forget that denominator, over h. So you simplified all the numerator, boom, we got this. So when I plug in 0 here, because that's what you normally do with a limit, right? You're going to get 0 over 0. But I look at this, look at this numerator. I'm going to take out an h. So see, both of these terms have an h, so it's h plus 1 over h. Because when you distribute, you just get the same thing back. And h divided by h is 1. And so you have the limit as h approaches 0 of h plus 1, which is what remains. And so now you plug 0 in, the limit as h approaches 0 of 0 plus 1, which is 1. And so that is the instantaneous slope at negative 1, right there. So the slope at negative 1 is 1. So if you look back here at our original picture, this slope at exactly this point is at negative 1 is 1. The slope at every other point is different. This slope is negative, these slopes are positive, but this slope right here at this point, negative 1, is 1. That's what we just figured out. So now we know. We good. All right. Nice job. Let's see if we can fit one more in their time. All right, so here you go. Find the instantaneous rate of change of f of x equals 1 plus x squared at x equals 3. So 1 plus x squared is 1. It looks like this, right? So that's 1. And then you have x squared, which is a parabola, at 3. So it's like this. So this is going to be a pretty steep slope. So like this could be 3 right here. So that slope at that point is pretty steep. Okay, so let's fix. So f prime of 3. So the slope at 3 equals the limit as h approaches 0. What does that mean? Yeah, that means that the 2 points are getting closer together, so you get 1 point in the instantaneous rate of change. Equals f of 3 plus h minus f of 3 over h. So in this case, I'm plugging in 3 instead of negative 1 because I'm finding the slope at 3. That's the difference. So now I'm going to plug in the limit as h approaches 0 of f of 3 plus h. So 3 plus h goes in here. So it's 1 plus 3 plus h squared. So I plugged in 3 plus h there, minus f of 3, which is 1 plus 3 squared over h. Cool. All right, let's just simplify. 3 plus h squared. We're going to box over here off to the side. 3 plus h, distribute, 9, 3h, 3h, and h squared. So it equals the limit as h approaches 0 of h squared plus 6h plus 9, which is this. Oh, don't forget that plus 1. Almost forgot that plus 1. So I don't have room to put here, so I'm going to put it right here, plus 1. Cool. So that's the first part. Minus, this is 3 squared, which is 9, plus 1, which is 10. Minus 10 right there, all over h. Looking good. Okay. So equals, this is 10 minus 10, which is 0. So the limit as h approaches 0 of h squared plus 6h over h. What do I do now? Oh yeah, factor out an h. That's what I did last time. Equals the limit as h approaches 0 of h plus 6 over h. This is 6, by the way, sorry. Now h divided by h is 1, and the limit as h approaches 0 of, now you plug in 0, is 6. So this slope right here is 6. Yeah, up 6 over 1, that's pretty steep, right? So f prime of 3, the slope at 3 is 6. Up 6 over 1, boom, got it. Nice job, everybody. Try and do the next one. Good work.